In the vast stillness of space, beyond the orbits of our familiar worlds, something extraordinary is happening. A rare visitor, an interstellar comet known as 3I/Atlas, has entered our solar system, passing near Mars in a moment unlike anything seen before. This isn't just another comet. It's a messenger from another star system, traveling for millions, perhaps billions, of years before crossing our cosmic neighborhood. And for the first time in human history, orbiters around another planet are watching such a traveler up close. NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express and Trace Gas Orbiter, and even China's Tianwen-1 mission, all have turned their instruments toward this faint, icy wanderer. Why? Because this object may hold the chemical fingerprints of another solar system, preserved since its birth, a direct sample of matter that never formed around our Sun. So what exactly is happening near Mars right now? What makes this comet so unusual? And why are scientists calling 3I/Atlas a once-in-a-lifetime event? It all began on July 1, 2025, when the Atlas Survey Telescope in Chile detected a faint, slow-moving point of light against the stars. At first glance, it looked like countless other icy objects astronomers spot every week: dim, distant, unremarkable. Officially designated 3I/Atlas, it became only the third confirmed interstellar object ever discovered, after Oumuamua in 2017 and Borisov in 2019. But this time, astronomers had an incredible advantage: they found it early. Its trajectory showed it would sweep within just 30 million kilometers of Mars, giving scientists the unprecedented chance to study it using multiple orbiters stationed around the red planet. On October 3, 2025, 3I/Atlas made its historic pass near Mars. Though 30 million kilometers may sound vast, in cosmic terms, that's close enough for instruments to detect gas, dust, and energy signatures emanating from the comet's coma, the glowing envelope surrounding its nucleus. NASA's Mars Reconnaissance Orbiter, MRO, famous for its high-rise camera that captures high-resolution images of the Martian surface, was reprogrammed for something completely different. It pointed its half-meter telescope not at the ground below, but out into deep space. Its goal: to detect brightness variations, tail distortions, and ripples caused by the solar magnetic field interacting with the comet's ionized gases. At the same time, the European Space Agency redirected Mars Express and the ExoMars Trace Gas Orbiter, TGO, to focus on the event. These spacecraft used spectrometers to analyze sunlight reflected off the comet, splitting it into wavelengths to identify specific elements and molecules. We may not capture every detail, but even partial spectra could tell us what this comet is made of, and whether its chemistry mirrors that of our own early solar system. China's Tianwen-1 mission also joined in, adding another perspective from a different orbital position. For several days, Mars transformed into a cosmic observatory, its satellites all working together to study an object that had traveled across light years of empty space. It was a collaboration unlike anything seen before: 3 space agencies, 1 planet, and 1 goal: to decode the secrets of an interstellar visitor. By studying it, scientists hope to compare alien chemistry to what we know from comets like Halley or Hale-Bopp. And the early data has already delivered a shock. This suggests that its home system may orbit a dimmer, younger star, or perhaps it was born far beyond its parent star's frost line, where CO2 ice can remain stable for eons. It displays what's called strong negative polarization, meaning it scatters light in the opposite direction compared to normal comets. This bizarre optical behavior hints that its dust grains are shaped or structured differently, possibly more porous or crystalline than anything found locally. That might mean the comet formed in an environment with completely different temperature and radiation conditions, giving us the first real evidence that planetary formation beyond our solar system follows other physical rules. The data from Mars orbiters and JWST is still coming in. But even the early findings are enough to make planetary scientists rethink what they thought they knew about cometary evolution. If 3I/Atlas shows signs of complex organic compounds, molecules like methanol, ammonia, or carbon chains, it could be proof that the building blocks of life are common throughout the galaxy. Whether that's due to incomplete data or deeper anomalies remains to be seen. But one thing is certain: 3I/Atlas is not behaving like a normal comet. Every molecule escaping from 3I/Atlas's coma tells a story of where it came from, what kind of star birthed it, and how planets form in alien environments. It's as if the universe has sent us a frozen message in a bottle, drifting across space for eons until, by pure cosmic coincidence, it crossed paths with our solar system. And this time, instead of simply watching from afar, humanity is ready, with robotic eyes orbiting Mars, telescopes spanning Earth, and the James Webb Telescope peering from 1,000,000 miles away. As 3I/Atlas continues its journey outward, it will soon fade from view, vanishing back into the deep interstellar night. But for a brief moment in 2025, it connected two star systems, ours and another, through light, dust, and science. It reminded us that our solar system isn't isolated, it's part of a larger galactic story, one filled with wandering messengers that carry the secrets of creation itself. So when we look at Mars tonight, imagine not just the red planet, but an entire fleet of orbiters staring past it, eyes fixed on a faint, icy traveler that came from beyond the sun's reach. And somewhere, deep in its frozen heart, lies the story of another world, waiting to be told. If you enjoyed this deep space exploration, don't forget to like, subscribe, and share. Stay curious, because the universe is far stranger than we ever imagined. Thank you for watching my channel.